Look at the weather.
It's beautiful here.
Non-stop rain.
Oh, man, it is a blazer out there.
It's cold and it's shivery.
It is cold.
Really coming down here.
I really enjoy your weather reports.
From the All Indiana Podcast Network, we're talking weather in a whole new way. From historical events to what's coming up, plus weather news, science, safety, fun facts, and more.
I like where this is going.
This is Weather Weekly. Weather Weekly with Wish TV Storm Track 8 meteorologist Marcus Bailey.
It's episode number 48 of Weather Weekly. Good to be with you here. Last full week of the month of January. Man, this is flying by here. I am your host, meteorologist Marcus Bailey. Good to be with you here from Indianapolis, Indiana, and Wish TV. Appreciate you tagging along here. Got a quick one here again this week, and man, it's just been so quiet here. Weather-wise, in terms of winter weather here around Indianapolis, did pick up a little bit of snow. Not much, but a little bit over the weekend. And our grand total, drum roll, 0.6. 0.6 for what should be the snowiest month of the year. And again, we're recording this on the 24th. Last full week of the month of January. Not many good snow chances on the horizon, which I'll talk about coming up in the forecast at the end of the podcast. But pretty bleak. So if things were to end as is now, this would rank the 10th least snowiest winter on record if we don't tally on any more accumulation in terms of snowfall over the next 8 days or so. Excuse me. It is the least snowiest since 2020, where we only picked up 0.3 inches of snowfall for the month of January. That was a pretty low snowfall for the year, if you remember. And just because I'm sure you are asking, there were 3 times that we only picked up a trace. There's never been a January where there's not been no snow, but there's been 3 where there was just a trace of snow for the month: 1960, 1944, 1942, and 89 and 33, and 1919 as well. We picked up only 1/10 of an inch of snowfall. By the way, I don't know if I said it. 2020, we picked up 0.3. I think I did say that. 1973 is in between 2020 and this year at 0.4. So there's only a few more years after that where we were less than 1 inch, 52, 98, 47. At 0.7, 0.8, and 0.9 respectively. So total 15 years that we've had less than 1 inch of snowfall for the month of January. So very rare territory that we are in right now, and it's fascinating that there are areas to our south and to our south and east that have more snow this season than we have picked up here in Indianapolis. Places like Nashville, Tennessee, far surpassing where we're at right now. A lot of Kentucky has a lot more snow. There's parts of North Carolina that has more snow than we have here, Virginia as well. So don't know if we'll get out of this rut. There's still a long way to go. Technically, February is the last month of the snow season, or the winter season, I should say, in terms for meteorological winter. But we all know that we can get our fair share of snow come March and even well into April as well. So we still got a long road ahead, and we say it often on this podcast. It just takes one good snow, and we're off to the races, right? Now, we'd have to have a real big one to kind of cut the deficit here, because we are still below 1 inch of snowfall total for the entire season, or for the entire winter season. And I believe at this point now, we're still below 1 inch of snow for the entire snow season. Because we did get a little bit of snow in late November. So we will keep an eye on that. I think the big story, and we'll talk more about this coming up in the forecast, but we got some really, really nasty cold coming our way this week. We've had a couple of pushes of Arctic temperatures, but they've never really been kind of long-standing, and we haven't gotten really, really, really cold to the point of, sub-zero lows and dangerous wind chills. And I think that we may get there through the midweek. As we get a kind of a cold front moving through on Monday, and then that's going to usher in some pretty cold temperatures here. And I think by Wednesday morning, you're talking wind chills about 5 to 15 below here in the city, but even colder still when you go up to, say, the northern plains or the northern Great Lakes. And you have to keep in mind that they've got a pretty decent snowpack that far north, so it helps yank the temperatures down. But for the next several days, areas around Minneapolis are likely only looking for numbers barely above zero. Chicago may only see numbers into the low teens if they're lucky through the midweek. So, yeah, looking pretty chilly here, so we'll keep an eye on that. Okay, so we're going to do a little more educational stuff since we don't have a lot to talk about in this week's podcast. But it got me thinking when I was doing the January kind of recap here of when I talked about the ice storm in Muncie, one of my more memorable weather memories that I have had in my lifetime. We've never really spent an extensive amount of time talking about kind of the different precip types and how they form, because we see it all here in central Indiana. So we're going to talk about the differences between snow and sleet and freezing rain. We'll even talk a little grapple as well. That's coming up next here on Weather Weekly.
Audible's romance collection has something to satisfy every side of you. When it comes to what kind of romance you're into, you don't have to choose just one. Fancy a dalliance with a duke, or maybe a steamy billionaire. You could find a book boyfriend in the city and another one tearing it up on the hockey field. And if nothing on this earth satisfies, you can always find love in another realm. Discover modern rom-coms from authors like Lily Chu and Ali Hazelwood, the latest romantasy series from Sarah J. Maas and Rebecca Yarros, plus Regency favorites like Bridgerton and Outlander. And of course, all the really steamy stuff. Your first great love story is free when you sign up for a free 30-day trial at audible.com/Wondery. That's audible.com/Wondery.
All right, it is episode number 48. Good to be with you here on this last full week of the month of January. We're going to spend a little bit of time. I know I've had some past podcasts, but I don't think I've actually had a dedicated podcast coming to you talking about the different types of wintry precipitation. And here in Indiana, we get all types of them. And again, before we hit the break, I mentioned what kind of got this thought process going was when I was talking extensively last week about some significant events that have happened in the month of January. And I distinctly remember the ice storm back in 2005 in Muncie that took out the power for over a week in some spots around Delaware County. Freezing rain is one of several different types of precipitation that you can get, and it's all formed by the different layers of the atmosphere. Now, we've talked a little bit about kind of how we forecast and stuff like that, and how we don't just look at what's happening at the surface, but you have to look at all the layers of the atmosphere, basically from the ground all the way up to the cloud layer, right? And all the way up to where planes fly, essentially, and where you get the jet stream, to kind of get a clear picture of how you're forecasting. Well, nothing is more true than that when it comes to forecasting winter precipitation, which, in my opinion, is probably one of the more challenging things to do. There's a lot of challenges when it comes to forecasting. Severe weather, certainly. Snow accumulation right up there. But I think probably the most difficult situations that a forecaster can get themselves into is when you've got an event where you're going to have some areas in your forecast zone that are going to have different types of precipitation, and you want to really ramp up the level of difficulty if you have a system that's going to provide you different time periods in one location of different types of precip. So there's a lot that kind of goes into it here, but you've got three main winter precipitation types. And I'm not factoring in rain, because obviously we can get rain any time of year, temperature dependent. But when you typically think winter type precipitation, there's three of them that you think of. It's snow, sleet, and freezing rain. And there is a difference on how all of those are formed. And it makes sense if you kind of think about it in a cross section, and that's how I'm going to kind of explain this to you, thinking a little bit three-dimensionally here, okay? So, keeping with the theme of thinking of the many layers of the atmosphere, where cloud forms and starts to push out precipitation all the way to the ground, what would you need for it to stay frozen? Which, if it stays frozen, you get snow. Snow is a frozen precipitation all the way through, right? So what you would need is pretty simple. You need temperatures that are below freezing from the cloud all the way to the surface. No fluctuation in between in those different layers. If you stay below freezing that whole way, then you're talking snow the whole way down. Now, you can have some different elements to that. We talk a lot about wet snow, dry snow, and that can be very much dependent on, does it kind of go through a warming process on its way down, to where maybe the snow melts a little bit and you've got a lot of these flakes that just are sopping wet and kind of cling to each other, and you get the big fat wet flakes, the real good packing snow, if you will. Or is it really, 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 really cold from the cloud and we stay cold all the way to the surface? That's when you get kind of the lighter snowflakes, not a real good packing snow, but you get a higher ratio, and that's when you kind of get into the 10 to 1, from 10 to 1 to 15 to 1 to 20 to 1 ratios. And I'll revisit that more in just a second. But basically, you need to have cold, below freezing temperatures from cloud to ground, okay? So if you think that as a cross section, if you were able to look at kind of a temperature diagram all the way up and down, you would have, temperatures below freezing all the way down. Now, in terms of snow ratios, I mentioned quickly kind of the 10 to 1, 15 to 1, 21. So, assuming that your temperature is near freezing, usually the golden rule is for every 1 inch of liquid that we get, it's 10 inches of snow. Okay, but that is assuming that our temperature is kind of around that freezing mark here. When you get into much colder situations, you start ramping that ratio up to where it's 15 to 1 or 20 to 1. If you're really, really cold, it could be up to 30 to 1. That's when you get the real fine, powdery snow, real easy to kind of blow around, not great for making snowmen and snow forts and that kind of stuff. But you can get a lot of snow with very limited precipitation, or liquid equivalent, if you will, okay? So that's how snow is made. Now, next in line is sleet. So what sleet is, basically, it's kind of like a chunk of ice. Now, in the wintertime, assuming that your temperature at the cloud base is going to be below freezing, how is that possible? If you are, say, below freezing at the surface and the cloud base in itself is below freezing as well. Well, you've got what we call a temperature inversion. So in kind of a normal setting, and I say the word normal tentatively because temperature inversions are not completely infrequent, but they're not as common as, say, what I'm going to explain to you, that typically temperatures get colder the higher up you go in these layers of the atmosphere. You think of climbing a mountain. Usually when you're climbing up a mountain, the temperature is going to be colder halfway up and all the way at the top than it is from when you started your journey at the bottom. So the atmosphere works the same way. But you will have instances where you get kind of a wedge of warmer air that's kind of in the mid-levels of the atmosphere. And so how sleet is formed is it begins as snow when it falls from the cloud. It then hits the shallow warm layer, and it's in there long enough that it melts it. But it's a very thin warm layer, so it's not in there for long. And then it comes back into below freezing temperatures, for several more thousand feet, and that allows for now that soppiness to refreeze, and it then falls more as kind of these sleet pellets, these chunks of ice, if you will, as opposed to snow. Okay? Makes sense? The last thing is freezing rain. Now, freezing rain, when I describe it to you, is going to sound very similar to how sleet is formed, but there are some significant differences. And this is why it is so difficult to forecast for winter weather precip types when you get into this kind of situation. So freezing rain, again, at the cloud base, starts to snow. We're below freezing. We have another temperature inversion. So you have another warm layer, or warmer, I'm not going to go warm, warmer layer of air that is in the mid-levels. This time, this layer is much thicker from top to bottom. So meaning the snowflake will then enter this deep warm layer. It's in it for much longer than it would be in a sleet setup. And so this allows that snow to melt, and it is now liquid. And then you get to the surface. And in an ideal situation, you're likely going to have that warm layer that's going to be above freezing all the way essentially to the surface. And then the surface itself is going to be below freezing. So what that allows then is that rain to freeze on contact. Does that make sense? So, I think people kind of get the misconception sometimes that you feel like it's got kind of an ice feel to it when we say freezing rain, like there's actually a frozen component to it, and that is not the case. It is like a normal rain that you would have in the spring, but the difference is everything at the surface is frozen. I guess a good example of this would be when we get in rain events, and the roads seem fine, but elevated surfaces, and I think this is another good point. When we mention elevated surfaces, what do we always say? The first things that you need to be aware of in any winter weather type of mode when you're driving are bridges, overpasses, on and off ramps, sidewalks, driveways, those kind of things. Elevated surfaces, especially though, bridges and overpasses, because they're going to cool more quickly and maybe stay colder more consistently than, say, just a normal road that's overland. So you can see that on like stop signs, on power lines. That's where you can run into big problems, even though the roads may be okay. These elevated, where there's no warmth from the ground to support trying to keep those temperatures warm, that's where you get, some of that ice forming. Vehicles parked outside is another prime example. Those will usually ice over before, say, the road will, or anything like that. So, just something to kind of keep in mind. Freezing rain is an extremely difficult situation to kind of unfold. I wouldn't go to say that it's extremely rare, but I would say out of the wintry precip types, it is a little bit more rare than certainly snow and sleet as well. Okay. So thankfully, because as I mentioned in last week's podcast, freezing rain is awful. It's garbage. You don't want any part of it, because even just a little bit of freezing rain goes a long way in making things extremely, extremely difficult to travel and to get around, and can potentially create power outages and even bigger problems as well. So those are kind of the three winter weather types here. What makes things difficult when it comes to forecasting is that there are times that you could have all three of those in one system in the same area, depending on how, a system kind of interacts. And so that makes forecasting extremely, extremely difficult. Freezing rain already is an extremely difficult task because you're trying to assume some things. How deep is that warm layer? Is the surface going to stay cold enough to provide a freezing rain event? Another thing that can sometimes throw things off is when precip falls, it is a natural cooling mechanism. So if your warm layer isn't all that warm, sometimes you can have that precip coming through, and the whole process helps to cool the air, and that may help to transition things fully to snow. Or, if you go from freezing rain to sleet, because you've shallowed up the warm layer a little bit. So there's a lot of factors that can kind of go into all of that. All right, last thing I want to talk about, which isn't really in the three major modes of wintry precipitation, but there is a phenomenon called graupel. If you're not familiar with graupel, the best way I always describe it on TV is it's the precip that kind of looks like Dippin' Dots. When it falls, little hailstones, but you could easily just kind of squish them. It's almost like styrofoam. So what ends up happening here, and it's kind of formed a little bit like hail, but what ends up happening is, again, you've got your main mode of precip is snow, but it runs into some super cooled water droplets that have stayed liquid on the flight down to the surface, and those water droplets collect on the snowflake and they freeze on contact, and they form this kind of spongy, icy kind of little ball. They're a little bit more common in the spring and the fall because the freezing level is much closer to the ground. But you can get them any time of year, but more typical in the spring and fall months. So that's what graupel is. So those are some of the wintry modes that we get during the winter weather season. So hopefully that enlightened you a little bit. Now, the big question that you're probably wondering, will we see any of that wintry precip here for this last full week of January? We'll have that forecast coming up next here on Weather Weekly. All right, here's a look at your forecast as we go into the final week of the month of January here. Final full week of the month of January. Precip-wise, pretty quiet for much of this week. I talked about at the beginning of the podcast the just ridiculous cold that's going to be coming down here through the really the middle of the week, where highs are going to struggle to get out of the teens and overnight lows will be in the single digits, especially Wednesday morning, and you're talking wind chills 5 to 15 below. So that's pretty nasty. However, there is a little bit of recovery by the end of the week. Disturbance out ahead of it should see our numbers getting back into the 30s, low 30s by Thursday. I do think there will be some flurry opportunity. It doesn't look like we get anything more than that in terms of accumulating snow, and we could have a little bit of that on Friday as well. Friday's going to be a little bit colder with highs only in the mid and upper 20s. Weekend looks dry. We're into the low and middle 30s and kind of hovering into that low 30 range early next week. So slightly below average, but outside of kind of this real quick cold snap that we're going to have for the middle of the week, not bad. The 8 to 14 day outlook kind of putting near normal temperatures on the fold through much of the state, and above average precip chances over the next 8 to 14 days, which would take us into the first full week of February. We'll see if that holds true. If we're near normal, that would at least give us a shot for maybe some wintry precipitation. The February outlook is now out, and it is calling for a low chance for above average temperatures and a pretty strong signal for above average precipitation for the month of February. Also a snowy month expected usually on average for the month of February. We'll see if that holds true. Again, it's been very, very, very quiet. I don't know if we'll get to a point that we're going to get anywhere close to average. Obviously, we've got a long way to go to get into the 20s. But you get the feeling, you've lived here long enough in the Midwest, that something's got to give and the gate's got to open up some point to get snow, right? So we'll see if we start to pick up the pattern a little bit here over the coming weeks. Thank you so much for checking out this week's podcast. We always appreciate your time. If you'd like to hear something specific, you want a topic covered, you want an interview with somebody, email me. Give me some ideas here. Marcus.bailey@wishtv.com. You can reach out on social media as well. Marcus Bailey Weather on Facebook and Instagram, and at Marcus Bailey on the Twitter machine. Hope to hear from you, and hope that you can join me next week for episode number 49 of Weather Weekly. And while you're here, make sure to check out all the other great podcasts, all part of the All Indiana Podcast Network.
Discover more from Storm Track 8 Weather and Wish TV. Online at wishtv.com, and when you follow Wish TV on Facebook. Plus, be sure to check out more great podcasts from the All Indiana Podcast Network now at allindianapodcastnetwork.com.